Welcome, Hornets. The next section of 1.1 involving models and graphs is working with X-intercepts, Y-intercepts, and multi-roots. So let's just make sure we understand what we're talking about. For this class, when we talk about X-intercepts, we are talking about a specific value on the X-intercept which contains a 0 for Y within the point. So although we consider the point of intersection a comma 0, A is the X-intercept. So this is important to remember. You're going to have to break up a point, and you're going to have to look at the X-intercept as the X value within that point. A point of intersection on the X-axis is a comma 0. But what we're talking about is simply A. A Y-intercept is therefore the specific value that is attached within the point that goes with 0. So B is the Y-intercept, and the point of intersection is 0B. A is the X-intercept, and it is contained within the point of intersection a comma 0. So please be aware, one of the things to remember is that when I talk about X and Y intercepts, when I ask for X and Y intercepts, I'm specifically asking for values. Okay? So please be aware of that. When I'm talking about X-intercepts and Y-intercepts, I'm talking about the value within the point, not the point. So if you give me a point when I ask for an X-intercept, or you give me a point when I ask for a Y-intercept, that will always be marked wrong in AP Calculus. Okay. Now this brings us to some basic functions that you have to know. For example, you have to know that a cubic has two extrema. These are called extrema. A polynomial will always have one less extrema possible than it has degree. So if I'm looking at a cubic, like this one here, it will have at most two extrema. A quadratic, which is just that U shape, has only one extrema, and therefore its maximum degree is 2. So a quadratic has only one extrema, a cubic will have at most 2 extrema, a quartic, which is a fourth degree polynomial, will have at most 4. Notice that when we have an intercept that touches the x-axis, this is considered a double root, as it forms that tangent. This x-intercept is a single root, and it goes directly through. This is as opposed to a cubic, and a cubic also goes through, but it now has a region where it's close to the x-axis. Okay? So this just goes straight through. This curves a little bit and goes through. A fifth degree polynomial does the same thing, but it has a longer portion of time or a longer interval where it's close to the x-axis. Okay? So the higher the odd degree, the longer it is going to be closer to the x-axis, but passing through it. For an even degree, such as a quadratic, it just touches and just immediately bounces back. So this is a double root as opposed to a quartic, which now has more of a bowl shape. Notice the interval over which the function is close to the x-axis. Okay? The higher the degree, the longer it is close to the x-axis on that interval. Very quick interval when it's a quadratic, a little bit longer when it's a quartic. It'll be even longer if it's a 6th degree. It'll be even longer if it's an 8th. Same with the odd, except the odd go through. Okay? And you have to be aware of knowing the difference between a double root, a single root, a fourth root, fifth root, triple root, double root, single root, etc. So be aware. In this, we're talking about roots. How do we look at a root? What is an x-intercept? What is a y-intercept? And multi-roots, how they are viewed. Now, this goes directly with the basics of functions. For example, it is my expectation that you are aware of all the information that involves a quadratic. Okay? That means that you know that a quadratic can sit on the x-axis and have a double root, or can go through and have two single roots, or lies above or below the axis and has no roots at all. Okay, that's important to keep in mind. So you are expected to know this. You are expected to know the forms of a quadratic, x minus h, the quantity squared, plus k. This is our hk form, and we know that our vertex point is hk. A is called the our not our dilation. Thank you. Excuse me as I forget. So we're looking at our dilation is the A value. That tells us how quickly it moves. Okay? A higher dilation makes it go a lot faster up. Please be aware that we have a lot of different rules that go with this. For example, if I have a value inside like so, B here is also having an influence on the dilation, but the dilation is equivalent to 1 over b. That happens when it's inside with the x, so when it's inside of the function. Okay, now we often see this in terms of function notation a, b, x. Here is an example of a dilation that is having 1 over b as opposed to a dilation that is having a. Okay, please be aware of that. This is function notation, and it is a review again of what you've done in the past. Okay, please be aware the graphs that I will expect you to have basic information about are like this one, where we have a quadratic that has an axis of symmetry. And the axis of symmetry is x equals negative b over 2a. We have our x-intercepts. The x-intercepts can be found by factoring. They can be found by using the quadratic formula. X equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. We also know that this b squared minus 4ac is called the determinant. It determines the nature of the roots. If we end up having a negative inside of that square root, we have imaginary roots, and this will represent this situation down here. If I have a rational number inside, such as 36, 4, 9, anything that I can take the square root of, this is going to give me two unequal, that should be plus minus, two unequal irrational rational roots when this value is rational, and it will give me a situation that looks like this. But the x-intercepts will be rational. They'll be identifiable, they'll be fractions or integers. If I have an irrational number here, something that I cannot take the square root of, we will end up having two unequal irrational roots. It will still look like this, but now the numbers are going to be decimals, irrational decimals that never end and never repeat. The last situation is when we get a 0 right here for the b squared minus 4ac. And that means that I am adding nothing, and I am subtracting nothing from my axis of symmetry, and I end up with this situation, therefore a double root. Okay? Now, your job is to know your quadratics. Cubics, square roots. You need to know absolute values. You'll also need to know your transcendental functions. So you'll need to know sine, cosine, tangent, and as we go through, we'll continue to work with their inverse functions. Frankly, any of the functions that you worked with in Algebra 1, Algebra 2, or pre-calculus, and therefore rational functions, exponential growth, exponential decay, logarithmic functions, and in some cases you might have even had logistics curves. All of these, I expect you to be able to have a basic understanding of how to graph and how to find various characteristics. Thank you very much.